Welcome to the class. In today's lecture, we'll discuss one more example on Anova, which is asked in your model question paper also. The given example is the following data show the number of worms quarantined from the GI areas of four groups of muskrats in carbon tetrachloride anthelmintic study. Conduct a Anova test. Okay, given data is there are four groups 1, 2, 3, 4. The data is given below. Okay, now solution. For that, first we'll reduce the data of the given data to smaller terms. Okay, how will we do? Subtract 30 from all the observations. Okay, what we'll get when you subtract 30 from this observation? Then we will get in the first column we have 33, 32, 26, 14 and 30. Okay, when you subtract 30 for the first column, what will we get? Here we get 33 minus 30. So, okay, we'll get 3, 32 minus 30. So, it is 2. Likewise, we'll get minus 4, 16 and 0. Minus 16, 14 minus 30. Okay. Now, in the second column, we have 41, 38, 40, 23 and 21. So, subtract 30. So, we'll get 11, 8, 10, minus 7, minus 9. So here in the third column, when you subtract 30, you get minus 18 plus 5, 16 minus 8 minus 19. And here it is 8, 13 minus 5 minus 17 and minus 4. Okay, this is the table we got from subtracting 30 each observation. Okay, why? Just to make easy. Okay, our calculation. That's it. Okay. Now, according to your Anova test, first step is what? First table we need to add all the values. Okay, with respect to column, then add square them. Okay, total value. Okay. So in the next table, so we need to write down the values as it is. Whatever subtracted values we have got now, it is 3, 2, minus 4, minus 16 and 0. And here it is 11, 8, 10, minus 7 and minus 9. And here it is minus 8, 18, minus 5, minus 16, minus 8, minus 19. And in the fourth column 8, 13, minus 5, minus 17, minus 4. Now add them. So when you add along this column, T1 is minus 15. Okay. Then T2 is 13. T3 is minus 24. And T4, it is minus 5. Add along the column. Then what is the next step? Next step is to square each T1, T2, T3, T4. T1 square is minus 15 square is 225. 13 square is 169. 24 square is 576. And 5 square is 25. And here add total T is T1 plus T2 plus T3 plus T4. So what it gives? It is minus 31. Minus 15 plus 13 minus 24 minus 5 is minus 31. Once you done with this, next step is to find the squares. Okay. We need to find the squares. Means we have to square all the observations. Okay. Of each column. So 3, 2, for with respect to first column, it is 3, 3 square, 2 square, minus 4 square, minus 16 square, 0 square, like this. Okay. Then it is 3 square, 9, 4, 16, 256 and 0. Okay. Next, second column, 121, 64, 100, 7 square is 49, 9 square is 81. Next is 324, 18 square, So it is 25, 256, 64, 361. So now it is 64, 169, 25, 289 and 16. Okay. Once you then sum of squares. Sum of squares is add along column. So 9 plus 4 plus 16 plus 256 is 285. It is 415. When you add third column, it is 1030, and fourth column it is 563. Okay. Once you add this, add all this. Grand total is was 285 plus 415 plus 1030 plus 563 gives us grand total as 2293. What it represents? It represents summation of xij square. Okay. This 2293. Next, once you prepare all these table values, then first next step is set the null hypothesis. Set the null hypothesis. What is that? H naught is equal to is what? Mu1 equal to mu2 equal to mu3 equal to mu4. Four types of groups are there. So all four values are equal. We'll assume. Next is to find the correction factor. So correction factor CF. What is the formula? CF is equal to t square divided by n. Okay. T square is what? Total t is minus 31. So minus 31 whole square. We'll get it from first table. Okay. Divided by total number of terms, total number of observations. Total 4 columns. Each column contain 5 terms. Okay. 961 divided by 20. When you divide, you will get 48. Okay. Therefore, total sum of squares. Okay. Sum of squares we denoted it by SSI. So it is summation ij x ij square minus correction factor. So what is that? So SSI equal to this is 2293. Okay. 2293. And what is correction factor? Correction factor is 48. This one. So SSI is equal to what it is? 2245. So 2245. Okay. Sum of squares. Total sum of squares. Next is sum of squares between the sample. Okay. Sum of squares between the samples, or you can say treatments. So it is SSB. So it is equal to summation over I Ti square divided by Ni minus correction factor. So SSB equal to what is this? T1 square by N1, T2 square by N2 plus T3 square by N3 plus T4 square by N4 minus 48. Okay. T1 square, you will get it from the table. Okay. Second table, that is 225, number of items 5 plus 169 divided by 5 plus 576 divided by 5 plus 25 divided by 5 minus 48. Where are these values? T1 square, T2 square? Here in the this value 225, 169, 576, 25. Okay. Items are 5. Okay. Now simplify it. 225 divided by 5 plus 169 by 5. Okay. So we'll get it as 45 plus 33.8 plus 115.2 plus 5 minus 48. Therefore, add and subtract, you will get 199 minus 48. So, SSB is 151. Sum of squares between the samples. So, now, therefore, what left now? Sum of squares within the sample. Sum of squares within the samples. That is SSW is equal to SSI minus SSP. SSI is 2245 minus 151. So sum of squares within the sample is 2094. Okay. Now, once we get all the values, we have to construct the Anova table. Okay. Now, Anova table is, so now the Anova table is this: source of variation, degrees of freedom, sum of squares, mean sum squares, and F ratio. So now I'll have column in source of variation between the treatments and within the treatments. Okay. And degrees of freedom is number of columns 4, 4 minus 1, that is 3. Then n minus k. Okay. Total number of terms are n 20. K is 4. So it is 16. SSB is 151. SSW is 2094. Now MST is what? SSB divided by degrees of freedom. That is what we denoted it by new 1. It is new 2. Okay. So it is SSB divided by new 1. So SSB is 151 divided by 3. So it is 50.33. And MSE is SSW divided by new 2. So it is 2094 divided by 16. So it is 130.87. So then what is F ratio? F ratio is MSE divided by MST. So it is F is equal to 130.87 divided by 50.33. So it is 2.6. Therefore, here degrees of freedom total you can calculate it as 20 minus 1. It is 19. Okay. Now, what is the evaluated value? Since the evaluated value is 2.6. Okay. And tabulated value is what now? F of 3, 16. Okay. 3 and 16 degrees of freedom. We need to check by using the table. Now in the table, from the table, F3, 16, just check 3 comma 16 is 3.24. Okay, here we have written 3 comma 16 is 3.24. What is our value now? F of 3 comma 16 is 3.24. Then evaluated value is F evaluated value is 2.6 is less than F tabulated value, that is 3.24 at 5% of level of significance. Then what we can conclude? Hence, the null hypothesis can be accepted. So, is accepted. There is no significance between the four processes. Okay, this is how we can do the Anova test for given example. Okay, all examples whatever I have solved till now on Anova, all are important, all are asked in model question papers also. In the next class, I am going to explain two-way classification and example on two-way Anova. If you are not yet subscribed my channel, do subscribe and support. Keep practicing. If you have any doubts, please comment in the comment box. Thank you.